A very warm welcome to everyone watching this video presentation. My name is Nikhil Ratan, roll number B21218, and I'll be the one introducing you with the members of our group as well as the project that we worked on. Our project name was Know Your Habitat and our group number was 9. So let me introduce you to the members of our group. Sindhuja, Gagan, myself, Jihan, Aziz and Shivam. We all performed various tasks and had various contributions in this project. And shortly after me, my colleagues will be explaining them. So what was the problem statement of a project Know Your Habitat? The main objective is to develop a platform, web or Android, that will perform a reverse image search and will tell you the object is present in the image. So the brief project description is that we had to create our own data set, mostly images, and then label them into the different classes that they belonged in. The user will have to input an image and a platform will classify the image into the different classes that it belongs to. The classes are this platform does a multi-class classification, which meaning our platform should be able to tell with a probability of presence of a specific class. Example, an image may belong to an academic block and then further belong to A13. The steps that were followed in this project were data collection, data pre-processing, and data modeling. So now I'll pass on to my colleague Shivam for the explanation of the next part.
Hi, my name is Siom Raj and my roll number is B20231. In this project, I will talk about the data collection. What is the data collection? Data collection is the processes of gathering and measuring information on variables of interest in a established systematic fashion that enables one to answer, start research question, test hypothesis, and evaluate outcomes. This project we collect the data from different locations like resident areas, academics areas, and hostels area. And the data set is more than 10,000 images, comprising of all academics building from A5 to A17, and most of the hostels and residential area. With this data, we will be able to build a model which will be able to differentiate between academics, hostels, and residential buildings, and also tell which academics or hostel building is it.
Hi, my name is Jihan Arora and roll number is B21252. So I will talk about data preprocessing. The model is as good as the data provided to it. Therefore, removal of noise is of most important. Also, as the images collected were in megabytes and different pixels, therefore they had to be reduced to uniform size. As the noise in data leads to incorrect prediction, so removal of noise is important. So, and as we reduce the noise in data, the time taken to train the model will also be reduced and thus enabling us to run more epochs. As we also know that mm, tensors are used to store data, they can be assumed as multidimensional arrays. So also we know that if we take an image, let's say of 8K quality, so how computationally intensive the things would get, we know. So the role of ConNet is to reduce the images into a form that is easier to process without losing features that are critical for getting a good prediction. This is important when we are to design an architecture that is not only good at learning features but also scalable to massive datasets. Due to this, the size of photos used was 320 by 320 pixels. Also, we have to ensure that the format of all the images fed into the model are of same format. So we stored all the images in an array to access all the images using a for loop. So this ensures that the data collected is modified and we can get the most out of it. Thank you.
Hi, my name is Aziz, roll number B21284. So I'll be talking about convolutional neural networks. A convolutional neural network is an deep learning algorithm that can take in an input image and assign importance to various aspects or objects seen in the image. And it can then use these weights to differentiate between images and uh, classify or name them according to our requirement. So A convolutional neural network comprises of three main layers, which result from an input image to its output, that is classification. The first and the most important layer is convolution layer, where most of the computational part takes place. What happens is we have an image, for example, in RGB form. So the input will have three dimensions: a height, width, and depth, which will correspond to red, green, and blue in an image. So we have a feature detector, also known as a kernel or a filter, which will move across respective fields of the image, checking if a feature is present in it. So this process is known as convolution. The next layer used is a pooling layer, which is also known as downsampling layer. It mainly conducts dimensional reduction and reduces the number of parameters in the input. The next layer is a fully connected layer. The name itself defines this layer. As mentioned earlier, the pixel values of the input image are not directly connected to the output layer in partially connected layers. However, in the fully connected layer, each node in the output layer will connect directly to a node in the previous layer. Thank you.
Hello everyone, myself Gagan Gupta, roll number B21189. I will be taking forward this presentation. As we learned about CNN and that we are using CNN for our project, now we'll be seeing where we will see into certain terminologies which are need to be covered. First of which is feed-forward neural network. As the name suggests, it is an artificial neural network in which connection between nodes does not form a cycle. Basically, it is a one-way network. And in layers, we use some activation functions. In every layer of our CNN, we use certain activation functions. There are many activation functions available which we can use, but we selected three and used in our project. First of which is ReLU, second is softmax, third is sigmoid. Now we'll see into layers in depth of CNN. What is a convolution layer? It is the main building block of CNN, which is basically the first layer of every CNN model. It contains a set of filters or kernels parameters of which are to be learned throughout the training. The size of the filters is usually smaller than the actual image. Each filter convolves with the image and creates an activation map. Every convolution layer has a polling layer attached to it. The basic purpose of polling layer is to reduce the dimension of the hidden layer by combining the output of neuron clusters at the previous layers into a single neuron in the next layer. And once we are done with the combinations, some combinations of convolution layers and polling layers, then we add some dense layers to our project. What is a dense layer? A dense layer is a simple layer of neurons in which each neuron receives input from all the neurons of the previous layer, thus called as dense. It's like our project can be classified into a multi-class project, multi-class classification project, and we are classifying an image into multiple. We are giving a image multiple labels basically. As an image, as suppose we give our model input, it is first classified into labels, given labels 0, 1 or 0, 1 or 2, which basically represent academic building, hostel buildings or residential buildings. If the output are either academic building or hostel buildings, and we are further classifying it into in its telling which building they belong to, actual building of academic building, actual academic building or hostel building. That's it.
Hello everyone, myself Sindhuja, roll number B21158. Here I'll be discussing what is loss function and which loss function we were using. Generally speaking, the loss function is used to compute the quantity that the model should see to minimize during training. For regression models, the commonly used loss function used is mean square error function. While for classification models, for predicting the probability, the loss function most commonly used is cross entropy. As our model is multi-class, we are using sparse categorical cross entropy loss function, which is having integer labels. When learning a deep learning model, you must adapt every epoch's weight and minimize the loss function. An optimizer is an algorithm or function that adapts the neural network's attributes like learning rate and weights. The choice of optimization algorithm for your deep learning model can mean the difference between the good results in minutes, hours, days. We were using ADAM optimization algorithm. ADAM is an optimization algorithm that can be used instead of classical stochastic gradient descent procedure to adapt network weights iterative based in training data. Stochastic gradient descent maintains a single learning rate for all weight updates and the learning rate does not change during training. Whereas in ADAM optimizer, a learning rate is maintained for each network weight and separately adapted as learning unfolds. Hence, it assists in improving the accuracy and reduce the total loss. Hence, coming to the conclusion of our model, the accuracy of the model is 99% and the number of models we built for multi-class classification is 3 and the Python libraries we used are TensorFlow, NumPy, Pandas, OpenCV and Pickle. Thanks everyone for your time and consideration and special thanks for our mentor Ayush Tiwari for guiding us in a right path.